Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. Allahumma aftah alayna hikmataka wa anshur alayna min khazaini rahmatika ya arhamar rahimin. Allahumma rizukna ya Rabbi fahman nabiyyin wa hifzul mursalin wa ilham malikatil muqarrabin fi afiyati ya arhamar rahimin. Walhamdulillahi rabbil alamin. Alright, so we are now in chapter 4.4, inverse function. So for this subtopic 4.4, we have two learning outcomes that are need to be achieved. The first one is we need to be able to show whether a function has an inverse and find the inverse of the function. And we also need to compute the inverse of a function. Alright, so let us start here. So please make sure that you have your notes with you. So if f is one-to-one function, so please write there one-to-one, then the inverse of f denoted by f inverse, so this is the way how we write f inverse, is the function formed by reversing all the ordered pairs in f. Alright, so if f is not one-to-one function, then f does not have an inverse and f inverse does not exist. So basically we need to know that only one-to-one function has an inverse. Okay, alright, so we have two methods to check whether a function has an inverse. The first one is by using algebraic approach, where we need to do fx1 equals to fx2, and we need to show that x1 equals to x2. And also we have the methods of graphical approach, which is basically we need to sketch the graph and we will do the horizontal line test. So we will discuss about these two methods after this. So this one should be called as HLT in short form. Okay, so let us consider this example. So determine whether the following function have inverse function by using algebraic and graphical approaches. So what we have here, so the first one is, let us try to use algebraic approach. So we have fx equals to 2x minus 1. As we have mentioned earlier, for algebraic approach, what we need to do is we will do fx1 equals to fx2. Alright, so where basically what we are doing is we are replacing this x here with x1 and also x2, and we need to make sure that x1 equals to x2. Alright, so we will have 2x1 minus 1 equals to 2x2 minus 1. So simplifying this equation should give you 2x1 equals to 2x2, and hence we just have x1 equals to x2. So let us write the conclusion. So since x1 equals to x2, so fx is a one-to-one function. Alright, so let us consider the next approach, which is a graphical approach, where we need to do horizontal line test, and then we will see how many points does the test cut the graph. Okay, so we have discussed on how to sketch the graph of linear function in chapter 4.2. So for this case, what we have is fx equals to 2x minus 1. So finding the two intercepts, we should get -1 here as the y-intercept, and also +1/2 as the x-intercept. And let us join these 2 points in order to make a straight line. Alright, so by using algebraic approach, we need to do horizontal line test. It needs to be sketched as the dashed line or dotted line, for example like this. Okay, so anywhere on your graph should be okay. All right, so I'm going to do like this here, and we can see that this horizontal line test only cuts the graph at one point. Okay, so let us try to do the conclusion. So since the horizontal line test, or HLT, so since the horizontal line test cuts the graph at only one point, so that means, okay, so that means fx is a one-to-one function. Okay, so which therefore it means that suppose when the horizontal line test cuts the graph at more than one point, so it is not one-to-one function. Okay, so let us proceed to the next example. Suppose that we need to determine whether this function x squared plus 2 have an inverse function or not. So basically there is no instruction for you to use algebraic or graphical approaches. So let us try to choose graphical approach here. So this is the quadratic function. So we have x squared plus 2, and we also have discussed on how to sketch this function earlier. So x squared plus 2, basically the plus 2 is the y-intercept here, and the minimum point. So the graph, we have positive x squared, so it is smile shape. So this is the graph. Okay, and we need to do the horizontal line test here. So please make sure that we sketch the line on the place that we have the graph. So basically here, all right, and it is clear that we can see this horizontal line test cuts this graph at more than one point. So basically it is not one-to-one function. So the conclusion for this one, so since the horizontal line test cuts the graph, so the conclusion is compulsory in exam, at more than one point. So where basically these two are the points here. Okay, so fx is not one-to-one function. Okay, it's not one-to-one function. And so that's all for this part. So we will continue for finding the inverse function by using property in our next video. All right, so that's all. Thank you for watching and listening. Bye.